Okay, Assalamu alaikum, everyone. Introducing myself, I'm Dr. Ghulam Mustafa Abdu, and I'm presenting this presentation on behalf of my student, Ms. Najwa Zakaria bint Tawfiq from Aerospace Engineering Department, 8K FUPM, Saudi Arabia. I'm also the co-author of this research work. The title of our research is Simulation-Driven Analysis of GPS Jamming and Spoofing Effects on UAV Flight Stability. I'm really glad that our research paper has been accepted for the presentation in the 15th edition of International Conference on System Engineering and Technology. So we'll begin our presentation in following a style. It's a conventional and very traditional class kind of style where we will discuss the overview of our research topic, and then we discuss some introduction along with literature review that summarizes the state of art approaches. Then, apart from that, I'll discuss the problem statement that we have today for our research. I discuss methodology and discuss some of the results as well, followed by conclusion. Moving ahead, UAVs are widely used in so many applications, and there is no doubt that they have been proved a key kind of element while performing several applications, either civil or military applications. The main issue with using or utilizing the potential of drone is that they can easily be targeted for spoofing and GPS jamming. Now, what are they actually? What do you mean by GPS spoofing and jamming when we talk about these two key terms? Jamming means that you are now creating an external interference, which is noise, of course, and then the drone is unable to understand the message signals that you are doing, and then that is somehow very common right now. The thing that is more dangerous than jamming is spoofing. Spoofing means now the control of your drone is actually in the hands of other people, and now they have now there is no control of yours on utilizing the drone for particular application. That is known as a spoofing, and these attacks are very significant and can bring imbroglio to the particular mission that you are doing, either civil or military applications. This study that we propose today is actually performing some of the MATLAB simulations to evaluate how jamming and spoofing can affect the UAV flight stability and how sensitive this topic is. And our main goal is to develop a kind of a navigation system which is free from these kind of attacks, either jamming and spoofing. So you can see a diagram over here that we have ground control station, and then we have a backup base station. These are the common elements when we are flying or maneuvering our drone. And then what they usually do, they actually create a spoofer junction where we can transmit the fake commands and share the fake telemetry data with your drone, and then it can easily compromise your drone easily, you know. So, what we have done in the literature review, we studied the UAV navigation under the umbrella of UAV navigation. We went through some guided navigation, satellite sensors, INS, and signal integrity metrics. And we studied some of the robust and resilient algorithms that can, you know, make your drone to follow the trajectory without any error, and without any spoofing or jamming issue. And in that, we discussed one of the references which are mentioned below. One is uh, in 2019, another one is again 2019, and the last one is by Shafiq et al. In 2021. We discuss some of those techniques and robust algorithms that help us to follow the trajectory when we are commanding our drone. Then we come up with another topic within the research, that is GPS jamming. And over there, we actually discuss the disrupts of UAV's ability to receive satellite signals. And then it lead us to some of the key metrics, that is BER, bit error, we call it, and then low SIINR and signal loss. And for that, we discuss some of the key research papers as well that actually helps us how to avoid GPS jamming. Same goes with GPS spoofing, where we discuss some of the threat assessment techniques when it comes to GPS spoofing and GPS last GPS detection, where we use or discussed GLRT and CNN and RNN for real time detection, how to detect them. Of course, without detection, you cannot assess the threat detection. So our problem statement is quite simple, that in real world attacks, you cannot control them. They are very less risky, and it's not always feasible that you fly a drone for any mission. Either it is critical, or it's critical in terms of defense application, or it's civil. So there's a lack of simulation based frameworks before we fly our drone, and then that results in spoofing and jamming of the GPS signals. So, without robust monitoring of drones, keeping the jamming and spoofing in point of view, I believe that this topic remains unfolded, and we are going to present that once you are ready for any drone mission, it's better that we first model them and evaluate our drone with respect to all vulnerable attacks and spoofing and security risk. So this is our methodology. We come up with some of the equations which are very standard in terms of UAV navigation model, then GPS jamming model, spoofing model, and these equations have been implemented in our research to just perform some simulations. Regarding the results, what we did when we put set these parameters which are in front of you, starting from GPS signal frequency, jamming, UAV velocity, then number of satellites, and spoofing attack power. We come and we saw that the magnitude of pulse waveform without jamming is this. And when we go with jamming, then you can see that there's a lot of inference, is coming on in the way of word drone. Same goes with the spoofing results that we have done in this particular result slide. You can see that the first one is logarithm results for our drone. So you can see that 10 out of 12 sites are spoofed when it comes to flying a drone in Swarm, for example. And then the spoof power advantage you can see in contrast with the average PMD during lift of n percentage. So, and in the bottom two graphs, they are showing the spoofer power advantage in decibel in contrast with number of alarms. How many alarms have been generated? It's better that when you are utilizing drones for any mission, it's better to program it in a way that it generates some of the alarms. So you can see over there, this graph shows number of alarms with respect to spoofer power advantage. And when it comes to number of spoofed satellites in terms of our PMD, we call it ESE, SUPMD in percentage. So you can see that how the things are varying, like out of 12 sites. So, keeping in view and summarizing these results for a research paper is that uh, it's better that when you are swarming a couple of drones, it's better that you put some alarm uh, in your code, so that if there is an inference that is generated to some of the It's beyond the magnitude of some pulse waveform, and if you're able to detect it, then it must generate some alarm. And because of that alarm, at least we can come up in a context that our drone is going to be spoofed or jammed, very soon by external party. So keeping all this view, we try to put it into our research paper that actually serves as a kind of a tutorial for a researcher which is into the research and into the implementation of a robust communication network for UAV. So, two things are very important. One is GPS inference, which is jamming, and then GPS commanded by fake signals, which is spoofing. So, it's better that we try to monitor those things. So, this entire research paper serves as a tutorial for our upcoming researchers, and even it serves a kind of a tutorial to undergraduate and postgraduate researchers that how we can model a couple of drones, and how much communication network is robust enough that it can handle the inference or spoofing. So you can see that in this particular diagram, you can see that out of 12, 10 satellites have been spoofed already. So in this way, our presentation, we kept it very in a simple way, because this is mainly the topic of my student. Maybe she could have explained it in a very detailed way. But the main idea, I hope you have already understood that our idea is that before you send your drone or couple of drones for any mission, it is better that you keep these two things in higher priority. One is inference detection, and another one is detection of a fake signal. And it can only happen when you have set some sort of alarm in your drone. So this entire research topic revolves around a general detection framework which consists of some MATLAB simulations, and it can serve as a tutorial for undergraduate and postgraduate researcher who actually want to detect the spoofing or jamming in terms of received signal and intensity or strength, and then autocorrelation about the inference signals and the real signals. And then with this, you rearrange the residuals accordingly. So and above all, in entire research paper, you will see that there are some metrics that are complementary in GPS receivers, and we are trying to detect those GPS parameters as well, that actually enhances the position travelers. And then we have INS and signal of opportunity that actually provides a fallback navigation. And we saw in our research paper that our GPS has been compromised, and we also saw that out of 12, 10 uh, drones or some of drones, they compromised and spoofed. So with this presentation, I would like to thank following people. Muhammad Ashraf Zulkifli is from UKM, Malaysia. My another co-author, Sana Hafiz, and Dr. Nurita Wati Muhammad Tahir from UITM. As I said, that this presentation was supposed to be delivered by my student, but due to her urgency, she was not here. So I would like to thank her as well to carry this topic. And this research topic has been supported by KFUPM, Queen Mary University London, and University of Glasgow, and UITM Malaysia. And with this, I would like to thank you. And if you have any Q&A, you can always write to me. My email address is gulam, gulam dot abro, at the rate kfupm.edu. edu.sa. And you can find me with the same name, Ghulam Mustafa Abdu, on LinkedIn as well. I'm more than welcome for any future collaboration. Thank you, ladies and gentlemen, for having me to present this research topic of my student with you people. Thank you once again.